What is pin check? Where is that? Right, so when we're checking a pin, yeah, the actual result is of type pin check. And then the ATM state depends on the result, I guess. So you have a result, the type of the result. Or is this resource? Whatever it's meant to be. Was this defined anywhere? Did I just skip over it? I don't think so. But this is like the result of your function and the state that the ATM is in. The result of your function and the... It's interesting that it's const. I suppose, yeah, because I suppose this is a function which takes in the result and then determines what the correct state would be. Fine. Okay. I can live with it. That seems reasonable. Here we go. A dependent pair type res identified as follows in the Idris prelude. So it takes a type and a function. I don't think Idris has, what's it called? It's called univalence. Cumulativity. No, not univalence. That's a cubicle/hot thing. Yeah, currently type is in type. Yeah, which is bad. You don't want that. Yeah, it's definitely growing. We definitely have a resource leak. Okay. So this produces a res, just a hash. Is that meant to be a prefix operator? Is that how I read that? Or is it infix? Because it takes in a value of type A and takes in a single use resource. No, a single use function. I guess this is of some type parameterized by value. Where this is, I suppose, meant to be a function type. Okay. Run ATM, yeah, does not give you any resource. Yeah, so we need the ATM to insert the card. Okay, yeah, and then this should, I believe, force us to do a split because we won't have resources in one of the branches. OK is pin check, and otherwise we have a single resource ATM, depending on OK. Yeah. Yeah, so we can't statically know what the result is, but we can statically ensure that the dynamic check exists. Yeah. We could use a sum type such as either. Single use either, yep. Arguably simpler, why didn't you do it? even before resolving the state. Right. Okay, so we check the pin, right, so we can still send, as long as we don't depend on the actual state the machine is in, we can still do stuff like this. Okay, that's fair, I guess. Oh, it looks like offside rule for indentation. Yeah, looks like offside rule. Okay. Linearity and exceptions do not mix well. I am not surprised. When we catch an exception, we need to know what the state machine was at the point it was thrown. We have to check every result, as in listing 3. We will end up with a lot of nested case blocks. A pattern matching bind, okay. I don't like that syntax, but okay, fine. A concrete implementation of session types would be a paper in itself. We limit ourselves to didactic session types and concurrent. Yeah, okay, CSP. Concurrent communicating processes, okay. Functions are total, yeah. That, yeah. Whatever. It's fine. It's dependent types programming language. That's fine. Yeah. Okay, so the actions a channel can take is send, receive, or close. Okay. And a channel is a bunch of action. Yeah, okay. Channel contains a message queue for bidirectional, yeah. I guess this video is just one, me carefully watching the size of this increase, and two, reading this paper. Okay, so we have a protocol, we can request or we can respond. Okay. Here's L again. Take the L. Single use channel and a value. You can get back a single use channel with the next. Right, so this produces the next action. This is a function that does that, I guess. Or the type, which I guess is actions are a type. Yeah, okay. So it produces the next action. Okay. Right, because we're receiving something. Right. So we want the result and the resource. Yep, and again, we have a close, which just consumes the resource. Fork, this is interesting. Give me a single-use channel. No, give me a single-use channel. Or, well, Yeah, a function that takes a single use channel. And I'll give you a client. Yeah, right. So this is the channel to the server, basically. And if you have a channel to the server, you can produce a client. Yeah, it's unsurprising. It's a monad again. Which is fine. Nothing wrong with that. Okay, a client can either request adding two ints or reversing a string. Okay. Command is request command. If the command is add, request a pair of ints and respond with an int. We can see how utils translates into a type for the client side by running as client utils. It's like, is this meant to be a type? Yes, it is, because protocol parens is a type. No, protocol parens is a type. So utils should be of type protocol, right, which is a function that takes a thing and produces. Okay, sure. Okay, so it's a function type, I guess. Okay, util server is give me a single channel to the server that follows the utils protocol. So I want to receive something from the channel.